So, hi everybody. This is going to be a little different than all the talks I've seen today. It's also about IPv6, obviously, but not only. It's about how to basically work with packet captures and sanitize them so that you can share them without basically using too much information. My name is Jasper Bongertz. I work for Airbus Defence and Space Cybersecurity. Airbus Defence and Space means it's not building the Airbus A380 and A350 and stuff, but it's the military and the satellite business. And in there, I'm in the cybersecurity range. So my normal job is that I'm a security analyst and a network forensics guy. And very often we need to share indicators of compromise, stuff like this. And as you probably know, in a military environment, you have sometimes networks that are really, really highly classified, and you cannot just pull a PCAP from there and give it to some vendor like, hey, your firewall is doing something wrong. That is really a big problem. So I started looking at sanitization of PCAPs a couple of years ago when I needed it for my speakers' presentations, and I think so far the most happy people about my work have been basically speakers at network analysis conferences like the Wireshark Sharkfist conference. Okay, sanitization in general. The goal is usually to remove critical stuff, but to keep enough information in there to keep it useful. And this original to sanitized ratio is quite, or may vary based on your goals. I mean, if you take a look on the thing on the left, that is something that the US government had to to make available to the public, and you can see that they didn't want to because there's like moreover and in that same something, and the rest is black. I mean, that is sanitized, of course, but it's not useful. I mean, it's only that they can say, hey, we made it public, but it's not like anybody's going to do anything with it except complain that this is useless. So what we need to go for is find a way to remove all the critical stuff, but keep everything in the file as much as possible to allow still working with it. Yeah, may it be like still being able to identify the indicators of compromise, or at least for network analysis, see what TCP is doing wrong, that kind of stuff. So it's quite similar to editing packets for packet replay. Packet replay means that you're modifying packets and replaying them onto the network, which is something where you need to be very careful, because if you do that to a live network, you can do really bad things to it. So sanitization is similar in a way that you're editing packets, basically, but with a different goal, of course. What you want to remove is usually sensitive stuff like user credentials. If you're having like an FTP session that is unencrypted, you see the username, the password, and everything. Very often also IP addresses. You don't want people to see the IP addresses in your network. Because if you make that public and you distribute a PCAP and the bad guys get it, they have like a very easy job of scoping out your network. Even more critical maybe is device and software information. So if you're distributing a PCAP with some, let's say, CDP information in there, which tells you this is Cisco device, something running iOS version 12 or older, everybody's going to look for vulnerabilities in that version, and it's much easier to attack then if you know what kind of devices there are. Then vulnerable protocols. Basically, if you have a custom written application, somebody is not looking at security when writing the application, which normally nobody ever does. They always write the application and security is like, when something goes wrong, we should have done it. So that may be something too. Well, and in the end, payloads, of course. I mean, payloads, that's the big problem. Payloads meaning everything that is on top of TCP or UDP. Those kind of things are very hard to sanitize. You can sanitize easily up to layer 4, Everything above that is really hard to do. And I'm not going to go into the greater details of this here, because it's good enough for a couple of hours of talk in another way, but here we're going to look at the relevance for IPv6. So what people very often do is this. If you ever looked at the Wireshark Q&A forum, where you can ask questions about Wireshark and how to use it and how to analyze stuff and this kind of thing, very often people just post a screenshot like this. And this is not a good way to sanitize things. This is basically a very bad example. And if the screen resolution would be bigger, you could see why, or see better why. This guy wanted to hide his IP address and his MAC addresses, which kind of worked because you can't read them anymore. But what did he forget? The hex bytes. Yeah, so if you go in there and basically reverse the hex bytes, you can read the address again. So what I did for this presentation, I basically goused them out of the picture. So not giving away his secrets, but I have the unmodified screenshot, of course, and I could easily tell his IP address. So in sanitization, you have one big problem, and that is, besides the thing how to sanitize without losing too much information, that you need to make sure that you're not giving away anything you don't want to. So you cannot expose any detail like this guy did. I mean, he exposed what he wanted to hide by forgetting that it was in some other place. So the very big problem of sanitization is, how do I make sure that I'm not accidentally exposing stuff? And that is not that easy. Well, there's a way to do this, but we'll see how we can get there without too much trouble. So that's basically doing it wrong, right? When it comes to sanitization goals, there's basically two kind of people who need it. Network analysts like I was for more than 10 years before I went into the network forensics field, more or less, and like Jeff, we often need the packets only up to the TCP layer, because network analysis very often resolves around TCP doing something wrong. So I don't care if somebody cuts away the payload of TCP, it doesn't matter, because I can still see retransmissions, packet loss, whatever. It doesn't matter if there's HTTP on top or FTP or whatnot, so I don't care. It's much easier for network analysts to sanitize stuff than for security people. Sometimes you need FQDNs, and FQDNs are a nightmare in itself, because if you want to replace FQDNs in a consistent way, you need to replace each domain part the same each time you look at it. So if you have like www.google.com and something.google.com, you need to replace Google with the same word every single time. So you need to keep track of what did you do with the original, what word did you replace it, and if the name is of a different length, your payload length varies, so your sequence numbers get broken, and that is a really bad thing. So there's a lot of things that can go wrong. So for malware, usually we do not care that much about Ethernet, ARP, IPv4, TCP, UDP. I mean, TCP maybe. There's some interesting research into TCP session man-on-the-side attacks, where you try to take over a connection by injecting packets into a live connection. This is something where, yeah, we could be interested in doing that, but I think Ethernet and ARP, I mean, ARP spoofing, everybody's like, I don't care, everybody knows this one. So not that important, but much more important is FQDNs, URLs, binary payloads, that kind of thing. So very often we replace the network information, but keep the payload intact. Yeah, so we throw everything away that will tell you which network this was found on, but we keep intact the information how the attack happened or what the payloads were. Yeah, because it's just coming from the internet and doesn't matter if it's in our network or somebody else, but we can share it that way. So for the tools, I've seen many people trying to edit PCAPs using hex editors, for example. Who's ever tried to edit a PCAP with a hex editor? A few of you. Okay. If you really have to, what I can recommend is the 010 editor. I don't know if you know this one, because it has templates that can help you parse a PCAP. So I think I removed. Okay. Whenever I put in the remote, my mouse doesn't work anymore. That's really nice. Yeah, so you basically go in here, and if you have a template for the packet structure, it can help you to find the correct byte sequences within the packet. So the 010 editor has the advantage of not having you work in the hex bytes all alone, but it can at least show you what kind of bytes are what structure. For that, you have these kind of templates here. And there's this PCAP NG template that I'm using. So it parses you the stuff. The only bad thing about 010, it costs a couple of bucks. So you have to pay for it. But it's not expensive. So the other thing is Wireshark can edit packets too. I don't know if you knew this. It only works in the GTK version, which means that if you're using Wireshark 2 point something, you're probably already using the Qt version, which can't do it, but Wireshark Legacy, which is GTK, has a feature that is not enabled by default, but you can go into Edit Preferences and say, Enable Packet Editor. And it says Experimental, which basically means if you find a bug, you can keep it. Yeah. All right, so if I do this and I open a PCAP file, let's say this one, I can go in here and say, let's go for this get packet here. I double click it. I can select the line I want. My right mouse button doesn't seem to work. Or is it, I think I have to say edit here, not double click it. So edit, then double click here. So it was the wrong order. Now I can say, well, I don't want bongerts.com, I want bongerts.net. Oh, I have to replace it in hex. No, that is bad. Okay, I won't do it. I just put something in there. What you can see now is that probably the TCP checksum is broken. You can't see it because the validation is disabled, but if I enable, it doesn't work here in this one too. The editor is like a little bit annoying sometimes. I enable the checksum stuff. There. Now you can see it's basically broken. I edited the packet so the checksum is bad now, which makes sense because it's not the original anymore. Okay, so if you want to edit packets in a very, let's say, slow way, but faster maybe than in hex editor, you can enable the edit feature here. And that only works, as I said, in the GTK version and only from 1.8 or 1.10 on, because that was the version where Wireshark learned to save modified PCAPs again. I think it was 1.8 because that was when PCAP NG was.
It's still packet by packet, right?
It's still packet by packet. So yeah, you need a long. Well, that's the reason why Bill is in here. You see, because if you choose manual editing, you need some time. Okay, then something probably nobody ever heard of. It's called Wire Edit. It's a free tool. Yeah, it just wants to check for updates. I don't care. And I think, yeah, this guy is a bit annoying because he doesn't support PCAP NG, and I'm a big fan of PCAP NG, other than Eric, who's doing the forensics class today. With that, you can edit PCAP files. So let's say I'm using my HTTP example. I have to save it as a PCAP now. Yeah, because Mikhail, who's coding this, doesn't care about PCAP NG. Okay, that should be doing it. where's the editor? There's the editor. Let's open the stupid file here. So now you have this packets here, and you can say in here TCP get I want to edit it. Hello. Okay, it doesn't let me. Why? No idea. Well, I'm not going to waste time on this, but you can see this is like another editor where you can do manual editing. The advantage it has over Wireshark editing is that you can do find replacements that will go over all packets. So if you say replace me bongets.com with bongets.net, it will go through the file and replace them all, and it will also fix the checksums. So that is kind of nice because it's more automated but not totally automatic. So these are, from my point of view, the best options if you want to do a manual edit. Very often you cannot escape manual editing because you have some very specific things that the automatic tools can't do for you. So very often you have a two-step process. You do automatic replacement and then manual editing for the rest that you still need to replace. Okay, so as I already said, the general challenge is the balance between removing details and keeping it useful. That is always the challenge. One packet versus many. If you only have one packet that you need to sanitize, it's simple, yeah. I had a challenge out at SharkFest last year. There was like 2 gigabytes per file. It was 2 files, so 4 gigabytes. You do not edit this by hand. I mean, there were millions of packets, so that was an automatic replacement. Protocol complexity, that is why we're going to talk about IPv6, because IPv6 is a very complex protocol when it comes to sanitization, much more than IPv4 actually. And that is because of protocol dependencies. You will see what I mean in a second. And then there's something that is called defensive transformation. Defensive transformation is the mechanism that you use to not accidentally expose critical information. Yeah, so to prevent exposing something you didn't want to, you use a process that is called defensive transformation. And I'll show you how it works. First of all, there's a couple of tools that are good for batch editing, Bittwisty and TCP rewrite. A few of you may already know these. In earlier times when I had to work on trace files, I usually used Bittwisty and TCP rewrite together in some sort of combined way and running them like hundreds of times on the same file to replace everything I needed, which was very annoying. Then there's PacketAnon, which is a very automatic tool by a German university team, which seems to be discontinued now. It hasn't had any updates in a couple of years. PCAP is a Chinese project, which from my point of view has a stupid name, because in Wireshark there's a library that is called libpcap, or well, basically it's the main library they use, and calling your anonymizer PCAP is like, okay, no other ideas or something. And then there's Trace Wrangler, which is my tool, which I'm going to show you. So, how to sanitize correctly, and that is important. What you need to do is you need to take each packet and parse it from bottom up. So you start looking at Ethernet, then IPv6, then TCP, then payload, and all the way up until the top. You extract all the values that you understand. That means that if you don't understand something, it will not be extracted. That automatically means you cannot accidentally expose it in the written PCAP. Then you sanitize all the values that you have by the rules that you want to do, and then reconstruct the layers of the packet from the sanitized values only. So if there's anything in the original packet that you didn't understand or that the tool didn't understand, it will not end up in the final packet. It will be lost. So you will end up with less than you had if there's something in there that you didn't understand, but that's always better than exposing something you didn't understand that is critical. Yeah, so that is what defensive transformation means. You read the packet, you try to understand as much as you can, you sanitize everything, you reconstruct the packet from scratch and write it to disk. So in that way, my tool is quite different from Wireshark, because Wireshark is reading packets and displaying them. I have to read the packet, understand it, just like Wireshark, but then I have to build it back together again. So I have to reconstruct it. So a small example, I mean, this is a very simple packet. Everybody can read those, really, right? Pretty simple. We see it's IPv6, right? Okay. So what you see here is like the MAC addresses, destination and source, and the other type. After that, we have the IPv6 details. Yeah. So this is basically what the program has to do. Now, if the program doesn't know what next header 58 is, it will have to say, well, I cannot pass this anymore, and drop it. So basically here that would mean if we reconstruct the packet with what we know by now, we only get Ethernet and IPv6 header, and after that it will be cut. So you get a very short packet basically. Who knows what 58 is? IPv6, yeah, very good. Actually, we will see in a later, or in the remaining time, that this is basically a neighbor solicitation. Yeah, so, but I didn't want to annoy you with now parsing this by hand all the time. So, about the wins that we have with IPv6, and that is something that I realized only after I already spent enough time or a lot of time on my tool. If you have a PCAP with IPv4 and you want to replace an IP address like 192.168.1.1 and 2020, can you know or can you tell if both the IP addresses are in the same subnet or not? And you can't, because you don't know the subnet mask. The subnet mask is not in the packet, so yeah, maybe they are in the same subnet, but maybe not. And it's always nice that if you sanitize an IP address, if you end up with the same IPs being in the same subnet again, so that you can tell there's a relationship between the two. They were in the same subnet. You can't do that with IPv4, right? But you can do it with IPv6 because you have the prefix that is always 64 bits. So if you see the same prefix, it means that the two IP addresses with the same prefix should be in the same replaced subnet or prefix net in the end. So this is quite nice because we don't have to guess anymore, are those two in the same subnet or not? Yes, they are. So IP address replacement rules. Possible rules include like black marker, which means zero out all bytes, which is like the letter that I showed you, black out everything. Do a full randomization, so randomize the prefix and the interface ID. Yeah. Then maybe you want a very specific replacement and say, I want a original address to be replaced by something very specific because you want to use a DB8 address for it or something. So it's always nice if you have the option to define the replacement pairs, like this original should be replaced with this replacement. Then prefix-aware replacement, so that if you're doing if you're having two subnet or if you're having a subnet and you say, well, this prefix should be replaced with this prefix. This is something you tried just a couple of minutes ago and it crashed, which is my fault, of course, because it's my tool. This is something that you can do also. It's basically like a prefix translation in a normal IPv6 network, but by modifying the PCAP. And if you do that, you can also, maybe you want to randomize the interface ID or just keep it because it doesn't matter anymore if it's randomized because it's in a different subnet. You cannot tell anymore which network it was. So if it's the .1 and or the :1 and the :100, why randomize it? I can just put them in the new subnet or to the new prefix and keep the interface ID intact. And then you can see, well, this is probably the router. This is probably something else. I mean, that would be nice not to lose too much relationship information. So it's always good if you can do that. So now it gets tricky because we have special IP addresses we need to handle. And what special IP addresses do we have? We have multicast, but first of all, we had the one that crashed your example, all 0. So if you have all 0, colon, colon, you should probably not replace it with anything else. First of all, it's not giving away anything about your network because it's all 0. It's basically a black marker already. And if you have a duplicate address detection, which uses this as a source, well, you want to see this was a duplicate address detection afterwards again, so it must stay the same. This is basically why it crashes, because it tries to replace it, I think. Loopback, like you said, loopback addresses shouldn't appear in a trace normally unless you've taken a very strange way of capturing those. You can do that, but it usually doesn't appear. And multicast. Yeah, multicast should stay multicast. It's not good if you move multicast IPs into a, let's say, 2000 range, because it's like really crazy in the end. Then documentation IPs. I mean, a documentation IP is made for being anonymous, kind of. So replacing this with something else, not that useful, probably. And then the biggest problem is if you have 2 IP addresses and, for example, you randomize them, there's a chance, even if it's highly unlikely with IPv6 because you got so many bits, that you get the same replacement for 2 different original IPs. Which means that in the new trace file you have only 1 IP, but originally there were 2 different. And this means that if you're doing some kind of randomization, you always need to check if you already have a replacement that is the same for somebody else, and then throw the dice again until it's unique. This is basically something where in IPv4 you have to be much more careful. In IPv6 it's almost impossible to hit this. Usually I tell people if you manage to get the same IP address by randomization, you should play the lotto because you're gonna win. Yeah. It's like always the same. If somebody asks me like duplicate address detection with random IP IDs or with random interface IDs, have you ever seen it? No, but if I do, I play the lotto because it can't happen. It can, but it's really rare. So IPv6 protocol challenges, and that is the main problem here. We have address dependencies between MAC addresses, IPv6, and multicast, and I'm going to show you in my demo what I mean. I have this neighbor solicitation. It's only 1 packet. I wanted to keep it simple so that everybody can see what I'm doing. The only problem here is that the screen resolution is really low. Let's make this bigger. All right, so this is a neighbor solicitation. Everybody knows what that is, right? I mean, we're here at an IPv6 conference, so you should know what it is. Then we have something very special here, the destination. Can you see? FF02 : 1 : FF02 : 6EA5. What's that? That is a solicited node multicast address. Everybody knows what that is, right? Good, because usually when I teach for Sylvia Hagen, nobody knows what it is. And I have to explain three times every day what solicited node multicast means. So basically, people have a hard time understanding how it works. You know how it works because you're here, and this is a security conference, so this is basics, basically. So I'm going to assume that you know what it is. If you don't, talk to me, talk to Jeff, talk to Enno. We're going to explain it to you probably. All right, so why is this packet problematic when you want to sanitize it? It needs to match everything inside the packet. So what dependencies do we have here? What? Yeah, the last 6 here, or the last 3 bytes, basically. What do they map to? Yeah, the last 3 bytes of the address I'm looking for. So what you can see here is 026EA5. 0 to 60A5. This here tells me what am I looking for, the full address. The solicited node multicast takes the last 3 bytes from this and puts it into the destination IP. So the 3 bytes in the end of that line needs to be the same like the last 3 bytes in the destination IP. And if I sanitize it, it still must be the same. So if I randomize any of it, I need to make sure that they keep in sync. So I cannot just randomize both of them like I don't care. They need to stay consistent. Now it gets more complicated because what kind of address is this one here? Is it privacy? Is it MAC-based? Is it? So it's MAC-based. Which means that I'm not only going to have to replace the IP addresses, but I also need to replace the MAC addresses, which is something that doesn't happen for IPv4 replacements because there's no dependency like this in IPv4. So if I'm replacing this, I need to find out what addresses do I have. Are they MAC-based? If they're MAC-based, I need to replace the MAC addresses first, then build a new FE80 address based on the MAC address, then create a new solicited node multicast address, which must match the new address, and then I need to replace all of it and put it back in, and then I'm done. No, I'm not, because I also need to make sure that the checksum is correct, and the checksum, as you know, IPv6 header doesn't have a checksum, not like IPv4. So the checksum that I need to update is the one in ICMP in this case, or TCP or UDP. In this case, it's the ICMP one here. And now the problem starts because I'm building from the top down. So I have to start with ICMP. When I start with ICMP, I know the FE80 address, but I know nothing about the layers below that, so I need to do a sort of a look ahead, like what am I going to do when I build the other layers? So I'm keeping a lot of information like in a cache, like this is going to be the address that I'm going to do, so let's put it here, then calculate the checksum. It must be correct, of course. Does it? Does it have to be correct? What if it wasn't correct in the original? What then? That is very interesting information if I get a packet where the checksum was bad. So if I recalculate the checksum and it's correct, now I lose the information that it was bad. So I should keep it bad if it was bad before the sanitization, right? How do I do that? Well, my first thought was, let's just randomize it, it works. But what can happen is, by a weird chance, I randomize it to the correct value. And then it's correct again. So how do I do that? Yeah, but still it could be the same after enough changes. So no, my initial idea was basically I calculate the correct one for the new packet and I add 1 to it. So it's bad in any way, in any case. Yeah. I presented this sort of checksum dilemma to some guys from CrowdStrike. I don't know if you know those. And they were like, well, wouldn't it be cool if you could have in the sanitized packet the same bit distance from the wrong checksum like in the original? I was like, you guys are too much. Okay. So there's a couple of good ideas, but I'm not going there, not yet. Not as long as stuff that Jeff is trying with my tool is broken, so I need to fix that first. Okay, so as you can see, sanitizing this kind of thing isn't easy. You need to keep a lot of things in mind and construct them together. And now I'm going to show you how I do it, or how my tool does it. It's really easy. It should be. It will probably crash because I only compiled it yesterday, which is my excuse why it crashed for you.
Just don't have any zero addresses, you'll be fine, right?
I don't have any zero address. It's just one packet. So it's called Trace Wrangler. Basically, it started out as a tool for sanitization, and that is what most people think of it. Trace Wrangler is by now not a tool for sanitization anymore. It's a tool for handling large amounts of trace files. So if you're working on more than one single PCAP, it can help you a lot. I recently had a job where we were looking at 0.5 terabyte of PCAPs, and I threw them in there and did all my stuff. And the funny thing is right now a vendor has the PCAPs and they're not getting anywhere because they can't handle it. So it's kind of funny. Okay, so what you do is basically start it, then we add our neighbor solicitation PCAP. You can click on it, it will show you some details about it here. Yeah, doesn't matter. And now what we're going to do is we add a anonymization task. And there's a lot of things that you can do here. You can tell it to remove the payload, which is something that I recommend unless you want to keep the payload. Payload means anything trace wrangler doesn't understand when parsing. So there's a point when going through the packet from the bottom to the top that trace wrangler says, I don't know what this is anymore. I don't understand the next bit. That is what I call payload. And if you keep this check mark in there, it will cut it away. So you will end up with a packet that ends at the correct byte where it didn't understand it anymore. And it's very exact, so it doesn't cut like at the same offset for all packets, but exactly at the spot where it didn't understand it anymore. You can cut it away, you can replace it with zeros, so if you want to keep the original packet size, you can do that. And you can also put in a pattern, like this was sanitized with something. So I usually cut it away. Then there's PCAP-ng. If you don't know the PCAP-ng file format, you can use comments in there. You can store name resolution information in there, which is kind of critical. Eric told a story yesterday about a PCAP that he got where somebody forgot that in the PCAP-ng file there's a block that tells you which name resolution was available to which IP address during the time of the capture. So the guy filtered the trace but forgot that this information was still in there, so Eric could read the iPad name of the guy and everything because it was still in the trace. So this one will sanitize it and remove it. Then you can do Ethernet stuff like randomize the IP, the MAC addresses and stuff like this. But for us, interesting is IPv6. So what you can do is, first of all, replace IP addresses by list. So if you have a specific IP address that you want to replace, you can just say, okay, I want to replace 2001 with FE80, something like this. Which means if trace wrangler, when going through the file, will find this original, it will always replace it with what you wanted. Yeah, so that is the first that it will look at. If that's not active, or even if it's active, the next thing is replace by prefix. This is what Jeff just tried, just replacing the network prefixes. And then there's the remaining IP address checkbox that should always be active. So if it doesn't replace by specific IP or by specific prefix, it will go to this option. And then you can say, well, randomize the prefixes and keep the interface IDs intact. So if it finds a new prefix, it will randomize it. But the interface ID will just be concatenated to the new prefix, and it will stay the same basically, just be put in another network, so to speak. You can also say, well, randomize both, which means the prefix should be new and the interface ID should be new. And randomize both in stateless mode, which means randomize it every single time. This is different from the other two in a way that as soon as I randomize a prefix, I will store it in a database, and when I see the same original again, I will use the same replacement so that it stays consistent. If you do this, it will randomize it every single time, so you get a completely different IP address for every occurrence that you have. So usually the best one is probably this one. And if you check include documentation addresses, it will also do that for documentation addresses, otherwise they will be left alone. Okay, so that is good enough. Let's just say I only want to do the IPv6 replacements here, like that. And then my task is complete. I can always double click it or edit it and do something else if I want to. So you can go in there all the time. If you have a good setting, you can also set it as a default profile. You can extract it from here and use it later again if you want to run the same replacement settings again. So now I run it. Hopefully it won't crash. No, it doesn't crash. Great. That was what I fixed yesterday. And now I have a new file that is called, you can see here, IPv6 neighbor solicitation _ anon. And that means it's anonymized. And there's my new replaced file here. It is different from the one that we just had. There was something with a E5 in the end or something. And you can see this here matches this one. The MAC addresses should be correct, 2066. So it did all the things internally and made sure that everything is still a match when it comes out of it. And it will do that for every packet that it finds. So whenever it finds something for the first time, it will remember what the replacement for it was and will always use the same replacement, so the file stays as consistent as possible. So this is what you can do. The only big thing right now that is missing for a lot of people is you cannot replace anything, or not a lot, on top of TCP or UDP. It gets really complicated, but for that I put in a payload replacement thing where you can say, I want to replace certain strings with other strings. So if you keep the payload intact, you can do string replacements. And you can use the syntax from Snort with the pipes if you want to do byte replacements like this. Yeah, because not everything is printable, so if you want to do that, you can say replace 010203 hexadecimal with ABC, and then it will do that if it finds it. So this is kind of a workaround to get some things in the payload replaced, because very often people want to change like SMB path names and stuff like this. If you don't like editing this in this slightly cumbersome editor, you can also export and import text files, which makes it easier for you to work in your text editor of choice, whatever you want. So this is my tool. You can download it for free. It's on tracewrangler.com, I think. It's IPv6 enabled, I hope. Really? Oh, strange. It should be IPv6 enabled, but
Even if it's not, I mean, you have not 6.4.
so maybe it's not my fault. Yeah. I don't know. Okay. Basically, it's free. It will be open sourced in the next release that I put out. I didn't have much time to do it. I'm overdue for the new build. The next one will be with full source, so if you want to take a look at the source code, you can do it. The only problem is nobody will probably ever going to compile it because it's written in Delphi and nobody uses this, except for me and the Russians, obviously, or apparently. That's because I'm a network guy, not a programmer, so I used whatever language I understood well enough to do something like this. This is like 200,000 lines of code by now, so if you want to take a look at it, you can do that, and maybe it helps you if you want to know the finer details of how it's replacing stuff internally. And that's basically it. I mean, if you ever need to replace PCAPs or PCAP NGs, go use it. If it fails, which happens a lot, let me know. There's a very funny dilemma here, because if I tell you, can you send me the PCAP, and you say, no, I want to sanitize it to be able to send it to someone, that's my basic problem all the time. But maybe you trust me that I'm not going to disclose it. I try to fix bugs as fast as I can, so I'm going to work on Jeff's as soon as I can. And any kind of, feature request is always welcome, if you will. So I don't know how I'm doing with my time, but I'm done so far. So if you have questions, now's the time. Yeah.
What license will you choose?
That is a really good question, and that is the reason why I didn't open source it yet, because I was like, there's so many of them. I'm probably going for GPL2 because Wireshark is using this, and Eric with his network miner tool is using that as well. But I haven't really finally decided. So if you can tell me, don't use it because, that is appreciated. Yeah, but it's probably going to be GPL something.
Or similar.
Yeah.
And the second question, I saw that it's just for Windows, so the
Yeah.
reason maybe is you wrote it in Delphi. I don't know
Yeah.
if you can run it on Linux except
It
Wine.
it runs on Wine, but other than that,
Porting it would be rather hard work.
the reason for me, and I always have to explain this because nobody writes stuff in Delphi anymore. The thing was, when I started this, I thought, well, I could now go and learn C for 5 years and still be a beginner probably, or I could use what I can already and get things done in the same time. So I decided against learning something new and fumbling around with it. And I mean, it's a really complex project. This is not using any libraries from anybody else. It's written from scratch. It reads even the bytes from disk with my own routines. It does all the dissection by itself. There's nothing that I imported from anyone. I spent, I think, a day alone on just the function to be able to check if a string is the correct IPv6 address. If you've ever done that, it's really interesting how many different ways of writing IPv6 addresses is correct or not correct. So I had like 400 test cases, and it was like running them in a unit test and crashing after the 10th, crashing after the 20th, crashing after the 30th, fixing it all the time. It was a full day of just being able to check that it works. Somebody said, well, why don't you use a regex? Because there's a DIN A4-page regex that can do that for you. But I'm working on millions and billions of packets, and regex is just too slow, so it needs to be faster than this. So there's a lot of work that went into this, and I didn't just want to go and learn C first to be able to fall on my nose all the time. So that is the reason why. Basically, I'm sorry, but you probably have to run it in a VM. Yeah, so. Okay, that's it. Thank you, and yeah, if there's anything else, just contact me, no problem.